Dealing with the snow in recent history has actually been getting easier in Rochester, but that's not necessarily good news. The past 5 winter seasons in Rochester have all gotten less snow than average, less than 100 inches.
Yeah, and interestingly enough, if you keep going back, you go before that, 4 of the previous 5 of those winters were above average. So I wanted to ask the question, is any of this related to climate change and a warming world? Climate change has changed weather.
Technically, it has its fingerprints in everything.
Dr. Jason Furtado is a meteorology professor and an expert in the relationship between extreme weather and climate change, and says winters are now warmer, turning some snowfall events to rain events, but not all storms.
In the wintertime, if we can get just the right cold conditions and the temperature is actually still warmer than it is, we can actually get heavier snowfalls to happen from those events.
Snowstorms require 2 main ingredients, moisture and cold air. As the atmosphere warms from climate change, it can hold more moisture. In regards to cold air, it's getting less cold. For us and our friends to the north, in the Arctic, where we get a lot of our cold blasts in winter.
The Arctic region, by far, is the most rapidly warming place on the entire planet. In fact, it's warming at rates 2 to 3 times anywhere else on the planet.
So a warmer Arctic could help break down the tight temperature difference from the poles to the tropics. But this is where things get a little complicated. That breakdown could impact the jet stream, weakening the flow of air overhead and changing our weather.
I think there's a little bit of still debate about that in terms of in terms of how much of that effect is actually being manifested itself within the jet stream.
It makes sense conceptually. Imagine this rope being the jet stream where we've got really cold air and really warm air. If there's a big difference, there's a lot of tension, it takes a lot of energy to move. If there's a small difference, there's less tension, and you can get big waves in that rope or jet stream that last a long time and cause extreme weather. It really is all about the Arctic, according to Dr. Jennifer Francis, a scientist that researches climate and its interaction with our weather.
We think that because the warming in the Arctic is so rapid and so much bigger than elsewhere, it's having an impact on the jet stream such that those waves are tending to be in a large sort of configuration more often.
A breakdown in the typical pattern means more extreme weather in all seasons, something Dr. Francis says is on paper in the science and on the mind of the common observer.
To someone on the surface, it feels like weather conditions are hanging around longer. They're more persistent.
This might be a clue as to why our past few winter seasons have been so fickle. The pattern has not favored snow, but climate change can quickly swing our weather in the other direction.
If you've got a very persistent pattern that lasts a long time, and then it abruptly shifts to a different one, you might call that weather whiplash.
So while seasonal forecasting with great accuracy is still hard, we can forecast what will come in the next few decades. Wild swings from season to season, week to week, and sometimes day to day. That's weather whiplash effect that Dr. Francis was talking about. You can have some examples right here locally, like when we get a freeze late spring after a bud break that caused millions of dollars in damage just in the Finger Lakes with some of the grapevines there. Similar things have happened up with the apple orchards as well. The weather whiplash can happen when you get those big swings in jet streams. That may continue to happen as we get increased variability from season to season. So we'll have big swings up and big swings down. Eric, over to you.